Okay, logicians, in my last video for the last section, I gave you a simple method for solving proofs involving involving implication rules. That method was about 3 steps long with a couple nuances. Now, we've added in replacement rules, and replacement rules work a little bit differently than implication rules, but really not much. Instead of being an argument form with various premises, we've just got logical equivalencies between different sorts of statements. So what I want to show you is my revised method for doing proofs that involve replacement rules. And this is really almost exactly identical, except which is like a couple nuances, right? But the same basic pattern applies. Here's the whole method. Let me walk you through it in an example. Okay, so let's say we've got this problem right here. We've got these premises. If S, then Q and M. Premise 2, S or P and L. Premise 3, if P, then Q and R. And the conclusion we're going for is Q and M or R. Okay, so as usual, I want to push my conclusion down, leave myself some space. Step 1 is still look for the conclusion inside the premises. Now, we don't see our whole conclusion anywhere inside the premises, but we do see the pieces scattered about. And namely, we see the simple statements Q, M, and R scattered through premise 1 and 3. All right, so what are we going to do with that? Well, step 2 is, what rule do I know that will let me prove my conclusion from that premise? Now, when we were just dealing with implication rules, I left it at that. But the truth is, there's no rule that will allow you to prove your conclusion from either of these premises or both of them together. So I want to revise that or add in like a new nuance. What rule do you know that will let you prove your conclusion from any premise at all, not just the ones that are given to you? Let me put this a little bit differently. Your conclusion, Q and M or R, it's a conjunction. The main operator is that dot, the conjunction sign. So the question you're asking yourself is this: what rule do I know that will let me infer a conjunction? What rule do you know that will give you as a conclusion a conjunction, an and statement? Because that's what you've got in your conclusion. And the answer is that there's 2 possibilities. Either the conjunction rule will do it, and that's an implication rule, or the distribution rule could do it. Both of those can give you a conjunction as a conclusion. So we're going to be thinking about both those possibilities in our heads at once. So a third step is that what other premise, if any, am I going to need in order to apply this rule? Or in this case, these different rules. So we've got 2 possibilities we can go down. One is if we use the conjunction rule, then we're going to need a premise that says Q and a premise that says M or R. And we're going to put those together with the conjunction rule. If we use the distribution rule, we're just going to need one premise. And it's a premise that says either Q and M or Q and R. All right, so which road should we pick? We can try out both of those possibilities. Now, if you really don't know which to use, you can try them both out and see which works. And if you hit a dead end and you can't prove it, go back and try the other alternative. Sometimes that's what you have to do. But in this case, I think if you look back at the premises, you might see which one is preferable. And that's what I want you to ask yourself. If there's multiple rules from which you could prove this conclusion, which is probably going to be the easiest to use? Well, I notice in the premises that I've got both of the disjuncts in my target conclusion. It's a disjunction, right? And one of the disjuncts is Q and M. Well, look, I've got that. All of Q and M is right there in premise 1. And then the other disjunct is Q and R. I got that too. It's in premise 3. I get a feeling that this is the way to go, that I'm going to be able to put this together more easily in a disjunction than this other route. But again, you can try them both out if you want. But let's go down this route right here. So here's what we'll do. This is the premise which I need in order to infer my final conclusion by distribution. So I'm just going to go ahead and write that down. And this takes me back to the beginning of the process, as usual. Now my question is, how am I going to get this premise, this disjunction, right? So again, I'm going to look for the premise, look for the conclusion inside the premises. And look, like I mentioned before, I see parts of it in line 1 and line 3. And because I don't see the whole thing anywhere, so I'm looking for the pieces. All right, and where do I go from here? The next step is this. What rule do I know, or rules, that will let me prove my conclusion from that premise or from these premises, or failing that from anything at all? Now, again, my target conclusion is a disjunction. So the question I'm really asking myself is, what rules do I know that are going to give me a disjunction as a conclusion? Because there's no rule that'll get me directly here. What rules do you know that will give you an or statement, a disjunction as a conclusion? Think about it for a second. That is right, friends. I know too. The addition rule or constructive dilemma. All right, let's think about what we would need to apply both those rules, right? What other premise, if any, do I need to apply this rule? So if I want to do the addition route, then first I'm going to need to prove one of the disjuncts. I'm going to need to prove Q and M. If I know Q and M is true, then Q and M or anything is true. Okay, so I could go that route. Or I could go the constructive dilemma route. Now, if I want to do constructive dilemma, here's what I need. I need something of this form, right? So I need two premises. One is if X, then Q and M, and if Y, then Q or R. And then I'm going to need a disjunction that says, well, X or Y. Now the X and Y's are just like stand in for those, could be anything. But the point is, this is where parts of it are determined by what we need by our target. So here's the question. If there's multiple rules from which I could prove this conclusion, which do you think is probably going to be the easiest to use? Now, I know a lot of you probably think addition is always the easiest thing to use. But in this case, it's not obvious to me that it is, because like, okay, if I need to get Q and M, how am I going to get that? Well, I could get out of premise 1. What, by modus ponens? Okay, to do modus ponens, then I'm going to need S. How am I going to get S? And it's like, well, I'm going to get S out of premise 2. How? I have no idea. So that's actually not an obvious route to me. Whereas if you go constructive dilemma, look, I've got everything I need, almost. Look, because like I've got if I put premise 1 and 3 together, I've got this first big monster premise that I need. And then the disjunction premise that I would need, I've almost got it, because it would need to be it would need to be S or P. Now line 2 is almost that. It's S or P and L. So for all these reasons, like I don't know quite what I'm going to do with the line 2 business yet, but I think, man, I'm going to go down the constructive dilemma route. I've got the pieces, they're just sitting there for me. All right, so I'm just going to go ahead and write down the premises that I need to do constructive dilemma. And now I'm back at step 1, right? I've got to figure out how I'm going to get these two premises. Well, let's start with the first one. The first one is actually the easiest, because I can get it just by doing, I mistyped right here. All right, sorry for that brief interruption. So this line 4 is going to be easy, because I can just put 1 and 3 together with conjunction, and boom, I've got it. So I've got my conjunction of two conditionals. That leaves me with this other line. And so I made it line 4 because I didn't have to posit any other premises. Like I already had all the pieces here. So I just went ahead and made it line 4. Now how am I going to get S or P? That's the only question I have left to answer. So of course, I'm going to step 1, look for the conclusion inside the premises. I've almost got it in line 2, but not quite, right? So I've got the pieces. So, but the question is, what rule do I know that's going to let me prove that my conclusion from that premise or from anything at all? The answer is there's no rule that's going to get me directly from premise 2 to my target conclusion. I'm so close, right? I can tell I'm close. Now, look, in this kind of situation, good people, I'm going to tell you to flex or even break the earlier principle that I gave you. And the earlier principle is always think from the conclusion upwards. Actually, sometimes in a case like this, think about what rule can I apply to this premise? Because maybe I can just start thinking, what can I do to line 2? Because it might get me closer to that conclusion. All right, so what rule can you apply to line 2? I mean, it kind of invites a certain replacement rule, right? And it's actually written on the slide. Yeah, that it invites the application of the distribution rule. All right, so let's just try that out and see what happens, okay? What if we were to apply distribution to premise 2? What would it give us? Here's what it would give us. It gives you S or P and S or L. Now, does that get you closer to your target conclusion, S or P? Heck yes, it does. Well, in fact, you're right there. Well, what rule do we need to apply then to line 5 in order to connect the dots and get all the way to our target conclusion? Think about your rules. It's one you know. Do you want a hint? It's an implication rule. You got it? Yes! Simplification. Boom! There it is. Now we're done. We have connected the dots. All we got to do is tidy up. All I did, add in numbers, and we're done. Okay, what is the moral of this story? The moral of the story is that same thought process, that same method that you learned to do implication rules is also going to work with replacement rules with just a couple more nuances, because you're going to hit spots where you've got multiple options of multiple rules that could get you to the same place. And you got to think about what's going to be most efficient. You might go down a dead end rabbit trail, but you're going to learn to see, okay, what's going to be the most effective and efficient way to get me to the conclusion I need. And then you're going to hit spots, like I just mentioned before, where you're actually it might be appropriate to think about from the premises downwards, right? And not just from the conclusion upwards. Like, okay, what can I do to this premise? That will help me connect the dots. And so you're kind of thinking about a couple steps at a time, where you kind of try them out in your mind. That is the basic story. But the big moral of the story, folks, the big moral of the story is what is going to help you do these proofs more than anything? Knowing your rules, dear friends. If you know your rules inside and out, implication and replacement, you're going to see the moves you can make. If you don't know the rules, you will never see the moves you can make. So learn those rules, and this method will show you how to apply them. Thanks.